All right, so we're building on this idea from last class where we made the if statement. And I told you I struggled with the idea of whether we should do ifs first or loops first. And I chose ifs because one of the loops has the exact same structure as an if statement. So we're going to review that structure. I guess, do I want to just delete everything and then write it all again? Or you just want to modify it?
Yeah, because that way we can see what
Okay.
similarities in structure are.
All right. So I'm going to start way up here. Um, and we're just going to discuss loops real quick. And actually, maybe. All right. So the if statement and loops. The structure of an if statement. You need an if, you need a condition, and then you need some event, right? This is the structure of an if statement. And this, when this condition is true, the event happens exactly one time. That's it, right? So an if statement fires, triggers, happens exactly one time. And that's good sometimes. That's all you need. However, the first loop we're going to talk about is a while loop. And the while loop structure is exactly the same as the if statement structure, except you replace if with while. And this is a little bit English, just designation, right? But while is considered a loop because while the condition is true, it will continue to run this event over and over and over and over and over again until something changes the condition to be false. So I am going to, I want to demonstrate a while loop straight. So I'm going to comment everything out. I'm going to make a new int main down here. Okay. So we'll do a really quick while loop. We're going to make an integer called x and set it to 0. And we're going to say while x is less than 15, and the event is that x is equal to x plus 1. So the first time it looks at the condition, x is equal to 0, we know that 0 is less than 15, and then it will run the event. 0 plus 1 is 1. When it gets to the closing bracket or the closing brace, right? The way that a loop works is it just jumps right back up to the very beginning of the loop. So now we've changed x, and x now equals 1. So it's going to go through the while loop, and it's going to look at 1 less than 15. Well, 1 is less than 15, that's true. Because this condition is true, it's going to go through the loop again and change x to 2. Start over, change x to 3. Start over, change x to 4. Start over, change x to 5. All the way up until x is 15. 15 is not less than 15. So then, just like the if statement, it's going to skip over the event and then keep running the program. Just like an if statement, you can have an else on the while loop. Remember, the else is just connected to the condition before it. When this condition is false, that's when the else happens. So I'm going to demonstrate by using a cout and printing an x and then a C out that says X, or we'll just say the loop has ended. Now I run this, and I have two errors. But why? Oh. Why is my else not working? Can I not use an else with a while loop in C++? Oh man. Sorry. That's a Python feature, not a C++ feature. You cannot use an else with a while loop in C++. You have my sincerest apologies for my confusion between languages. So when the while loop ends, it's just going to jump to the next line. This will effectively do the same thing I wanted it to do. So what it's doing is it's printing out X 1, 2, 3, 4 all the way up to 15. And then it's saying the loop has ended. Now, I'm going to turn this down to 5, actually 4, so we can see it a little bit better what's happening. Because our code always reads from top to bottom, right? It always reads this line before it reads this line before it reads this line. When I'm running this statement, it's printing out that X is equal to 1, and then it's going through and printing out that X is equal to 2, going through printing out that X is equal to 3, going through printing out that X is equal to 4. And then it kicks you out of the code. So if I run it, you'll see 1, 2, 3, 4. And then the loop has ended. If I were to print out the value of X before I changed X, what's it going to print out? So previously, I was printing out the value of X after I changed X. I'm going to move this and I'm going to print it out before I change X instead. Print 0, 1, 2, 3 instead of 1, 2, 3, 4. That's a really minor difference, right? But the order of your output is important. The order of your code is important because swapping these two things changes the output that your code is working with, right? Even though the code's doing the exact same thing, it's still only looping 4 times, right? What it prints out is different. And you could print out X times 5, and then you're getting 5, 10, 15, and 20 instead, right? The power of loops is almost always mathematical, right? It's something when you need something to happen over and over again and get some sort of output from it, right? The loop is really the only way to do that. We've done this same concept using nested if statements, and you can do that, right? We only had 4 nested if statements. It's kind of a pain in the butt and clunky, but you could do it. But a while loop, you can have 400 nested if statements in one while loop, right? And it cycles through. So that's the first structure of a loop that I wanted to talk about, was the while loop.
Tell me that stopped working for me.
So the structure of the while loop, it's still nice when your brackets line up. As I said before, mine don't line up because that's not the way that I learned to code. and old habits die hard, but it's best if they line up. So that's the while loop. Now, the while loop, generally, the purpose of a while loop is you use it when you don't know how many loops you're going to go through, right? Now, in this example, we can math exactly how many loops we're going to go through, right? But generally, the purpose of a while loop is you don't know. It could run 50 times, it could run 3 times, it could run 3,000 times. You don't know how many times it's going to run, so you use a while loop. The opposition to a while loop, opposition is not the right word. The other loop that we want to talk about is a for loop. The structure of a for loop is a little bit different than anything we've looked at so far. A for loop has to have a couple of things. It has to have an initialization, has to have a termination, and it has to have a step. The initialization is some variable, in this case, int I, some variable that you're giving a value to start the loop. The termination is at what point does that variable stop the loop? And then the step is how much does that variable increase every time the loop runs? So this is doing the exact same as our while loop did before when it was less than 15. We started with an x. We created x and set it equal to 0. It's the exact same as initializing I and setting it equal to 0. We ran the loop as long as x was less than 15, which we're doing here as long as I is less than 15. And then we did x is equal to x plus 1, which is the same as I plus plus. It's increasing I by a value of 1. So we could now do the same cout and just use I instead. And for the demonstration, comment those out. When we run it, it's the exact same thing as we had before. 0, 1, 2. Because when I starts, it's 0. But the structure of this feels a little different. Because with a while loop, the event happens immediately after checking the condition, right? The loop checks the condition. When the condition is true, it runs the event. A for loop does the exact same thing. But by nature, everything we've talked about up to this point reads from top to bottom. And that's all it does is from top to bottom. But the for loop checks the condition here first. Then it runs the event, and then it does the step. It's the only exception outside of functions that we create, right, where it doesn't necessarily read directly from top to bottom. It treats this the first time it runs the loop, it initializes I equal to 0. But then this never gets looked at again. Then it's looking at the condition, which is the same as the while loop. And then the event, which is the same as the while loop. But then the step at the end. And then it does the condition again. Event, step. Condition, event, step. Until the condition returns false. Make sense?
We're gonna say this.
No, ask it.
No, so where you put your I there, is gonna be a little different, like. Whether you put it before or after the statement, because you're not incrementing.
What's cool about a for loop or a while loop, right? By nature, we picture things counting up, right? And by this, it's starting at 1, or we're going to start it back at 0. We're going to go back to 15. And I++ is a step. This is how much the variable I changes every time it goes through the loop. We could set that to be a step of 3. I is equal to I plus 3. So now when we run it, and I'm going to comment out my while loop again. When we run this, we should get 0, 3, 6, 9, 12. Once I equals 15, the condition returns false, and then it stops. So that's our step now is 3. But our step doesn't have to be an addition, right? We could set I equal to I times 2. Then we run it. We're going to get a bunch of zeros, and it's going to run forever. Because I started with 0, and that was a mistake. We started with 1 and run it again. We're going to get 1, 2, 4, 8, would be 16. But 16 is greater than 15, right? So we have an error. But for those of you that have taken microprocessors or understand or comfortable with the concept of bytes, bits, right? If we turn this to 257, you get squares of 2. 2, 4, 8, 16, 32, 64, 128, 256. We're familiar with those numbers, I hope. Yes, 512. Okay. You can turn it to 2570, doesn't matter. And your computer can do that math really quickly. So, these are the benefits of loops. You could decrement. So you could, instead, you could start at 2570, right? Go all the way down to 1. And then do I is equal to I divided by 2, right? Oh. Normal program termination. Why didn't it print my I's? Oh, because I is not less than 1. I is greater than 1. Pesky less than greater than. I used 2570, which was wrong, but you get the idea. Now, this is interesting because 1285 divided by 2 is 642.5. It's doing integer math because this is an integer. It's getting rid of the decimal. So it goes to 642 to 321. This should be 160.5, but it ignores the 0.5. Goes to 80, 40, 20, 10, 5. Should be 2.5, ignores the 5, goes to 2, right? Your loop is going to use integer math. You will not ever have a float in a loop. It's going to be an integer. Don't use a float. By best practice, common practice, your integer inside of your loop is an I. The I stands for increment. It's just always been an I. Everyone has used an I. Python does not always use an I, but in every other language, the general practice is your integer starts as an I. Now, just like if statements, am I recording? Did I turn that back on? I did. Just like if statements, you can nest if statements, right? We talked about that. We had nested if statements. You can also nest for loops. So I'm going to start back at I is equal to 0, I is less than 10, and we're just going to do an I plus plus. So this increments I from 0 to 10, one at a time. We can nest inside this loop a second loop of j equal to 0, where j is less than 10 and j plus plus. Now, this gives us a really interesting opportunity. the way that this works, and this is just, we have to look at it as reading in the order that our program is going to read. Also, Ethan joined us online, so he is participating in class, and I haven't said anything, so now I have acknowledged that Ethan is online. So, this is a cool thing. I told you before, the first time it runs through the for loop, it initializes the variable. And then it never looks at initializing that variable again. And then it looks at the condition to test if the condition is true. As long as the condition is true, it runs the event. Now, in this case, the event happens to be another for loop. So I starts off at 0, and then it starts this event. In this event, J starts at 0. J is compared against the condition J is less than 10. As long as it's true, it runs this event. And then it does the increment. And then it does the condition. And then it runs the event. And then it does the increment. And then the condition, and then the event, and then the increment. All the way up until the condition is false. Once this condition is false, it jumps down and it increments the first variable, checks the condition, comes back down and starts this whole loop over. It initializes J back to 0, and then it starts going through the loop again. So I'm going to create a variable called counter, and I'm going to set it equal to 0. I'm going to do counter plus plus, and then I'm going to see out counter. No. Counter plus plus, and then at the very end, after both loops are over, I'm going to see out counter. Without running it, using your best guess and math, what do you think is going to output to the screen? What value is counter going to be when this whole system is over? All right, so what I just missed was when we run it, it goes to 100. And the reason it goes to 100 is because I starts at 0, and then J runs from 0 to 10, and then it jumps back up to the I loop, and I goes to 1, and then J goes from 0 to 10. And then it goes back to the I loop, and I goes to 2, and then J goes from 0 to 10. And if we run this, we can see I is 0, and then it runs J 10 times from 0 to 9. And then I is 1, and then it runs J 10 times from 0, J from 0 to 9. I goes to 2, wherever it is. J goes from 0 to 9. I goes to 3. J is 0 to 9. So J happens over and over and over and over again because J is the event for the for loop for the I. So the way that the for loop works, it declares the variable. Then it checks the condition. As long as the condition is true, it runs the event. In this case, because the event is another loop, it initializes J, and it compares the condition for just this loop. And as long as this condition is true, it's going to continue to run just this for loop over and over and over again until this condition is false. Once that condition is false, it's going to jump down. It's going to get to the closing bracket, which tells it to come back up, increment the I, and then check the condition again. When that condition is true, it's going to come back and run this event. The cool thing about this is because the for loop initializes J at the beginning of the loop, J ceases to exist. J does not happen outside of this loop. If I tried to put an std cout here for J, I'm going to get an error because J does not exist outside of these two brackets. Don't make me a liar again, C++. It's the cool thing, another cool thing about loops is this variable is just for the purpose of the for loop. Now, while loops are a little bit different because while loops, usually you have a condition and that condition you've created before you get to the loop. So this variable will exist outside of the loop. But in a for loop, it does not.
Is there any way to make that global?
You could, like I could use X, right? I've already declared X up here. And I could say X is less than 10 and X plus plus. It would.
Let's talk about the J.
I could make the J. I could use the X for the J instead, right? But then I'm not declaring it at the beginning, right? The dilemma with not declaring it at the beginning, remember a for loop specifically, the idea is exactly how many times it's going to run. You have the initialization, you have the termination, these two numbers because you set them, right? So you know how many times it's going to run. If you put a variable in here that can be changed outside of the loop, then that could change somewhere else how many times you want it to run. Now, that's might be something you want, but when you do it, you have to be doing it for a reason. Because in general, a for loop, you're going to initialize inside the loop. You don't want it to exist outside most of the time. So with I and J, in this case, we have another really cool feature, and I think you're going to like it. Because we have I and J and they interact together, we can create a grid or a grid system. So by that, I mean we can have I and J, and I am going to put them in square brackets. So we have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. These can represent points in a graph. If we get rid of this end line and we put the end line here, then we get something that actually starts to look like a graph. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, all the way up to 0, 9. And then we start with 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, all the way up to 1, 9. And then 2, 0, all the way up to 2, 9. I'm using the double colon, syntax that you probably are more familiar with when dealing with coordinates. It's just a comma. 0, 0, 0, 1. Does this feel more like a graph that you're familiar with? Now, because we have a graph effect where we know where everything is, we could assign values into this individual graph. So we could assign a value to slot 4, 4. We're not going to do that today because that's using something called arrays, which we haven't learned yet. But the for loop allows us to travel through graph-like data relatively quickly, consistently, efficiently. So the nature of loops, the terminology generally used is called a repetition structure. You are repeating something over and over and over and over again. There has to be, for a for loop, an initialization, a termination, and a step. The termination is just a condition. So you could just call this a conditional. In a while loop, the same structure as an if statement. You have a while, you have a condition, and then you have an event. For loop, initialization, condition, step, and an event. And then nesting for loops is cool, in my opinion. You can also nest while loops. You can also nest an if statement inside of a while loop. You can nest a for loop inside of a while loop. And you can do all of those interchangeably. You can have an if statement that then triggers a while loop in the nest. You can have an if statement that has a for loop inside of it. There's no designation that doesn't work. Because when you're writing code, sometimes, almost always, you're going to have if statements that are changing what's happening. But even in a repetition structure, that being a while loop, you'll still have those if statements underneath it. I can scroll wherever you want me to scroll.
Just that.
Here.
That's within, okay. So the only way that you can print J is if it's within that.
Yep. If I tried to print J down here, it would give me an error because J does not exist outside of this for loop.
And it doesn't matter where you increment the counter. Well, no, that has to happen in that loop too.
Yeah, yeah. If I implemented the counter out here, which I could, right? Instead of being 100, it's only going to be 10. Right? Because I only happened 10 times. The I loop only happens 10 times. The J loop happens 100 times. Right? Because it happens for each value of I. So when I is 0, the J loop happens 10 times. When I is 1, the J loop happens 10 more times. When I is 2, the J loop happens 10 more times, over and over. Now you can do some really, really crazy stuff with this, right? Because right now, we got I from 0 to 10, and then we have J from 0 to 10. But you could do, let's just say for the sake of argument, I from 1 to 11, and then J from 0 to I. And then we're going to print IJ. This is going to look a little bit different than our graph, right? So the first time, the J loop only runs once because I equals 1. The second time, the J loop runs twice because I now equals 2. The third time, the J loop runs 3 times because I equals 3, 4 times because I equals 4, 5 times I equals 5, right? Once you start coordinating loops together, you can do some really cool stuff with them. But the general structure, you have to have a for, initialization, some condition, and then some step. And that's the structure of a for loop. And I've spent a lot more time on the for loop structure because the while loop structure is just an if statement. It just happens to run more than once. The reason we have included time.h is so that we have the capacity to work with random values. So there is a, let's come back down to my main here. So in this case, we're just going to set x equal to random percent 15. Rand percent 15. And then we are going to do a cout x. So just to show you what it does, and I'm going to get rid of everything else because I don't need it right now. So all this code is doing is running this rand percent 15 and getting a cout of x. So when I run it, x is 0. That's not good. Run it again. X continues to be 0. This is bad. But what if we did x equals rand percent 12? Don't be 0. Be 0. Fine. I'll just do it again. We got 0 and then we got 92. We run it again, we get 0 and then we get 92. I'm very frustrated that the first number was 0, but first number was 0. So we get 0 and then 92. This isn't super random, right? It is random. The number that it gives us is random. I chose 129 the second time. I would get 0 and then I would get 104. But every time I run it, I'm going to get 104. If I could pick 1005, I'm going to get some number. 986. Yes.
Would it be less than or greater than 1,500, or does that not matter?
What does that mean? What's your question?
Does the number that you put there influence the number that it generates?
Yes.
Or no?
So the way that this works is this rand function, right, tells the software that it's looking for a random number. It's giving it a random number. And then this percent 12, without going into too much detail of what that means, is just telling you that that number is going to be between 0 and 11. This number will never return, right? But it will return every number between 0 and the number directly below your cap here.
Yeah, but okay, so it would never be like 15 there then.
Right. This one would never return 15, but this one would never return 1006 or 1005, right? So the number that you put here is the maximum value. Now, if you wanted it to be between, let's say you wanted it to be between 10 and 20, right? Then you would just random percent 10 is going to give you a number between 0 and 9. And then you're going to add 11 to it. And that will give you a number between 1 and 20. Right? Is that right? Between 1 and 20? 10 and 20. 10 and 20. So that's how you can modify it. But you can also do other math with it. But in this case, we're just going to do the random percent 10. But it's not random. So when we talk about random values in code, outside of really, really high level code, we only get something called pseudo-random numbers. The reason it's a pseudo-random number is because it uses time to generate the number. Time is something that we can recognize, something we can interact with, something we can see. And the value of time, when I run this, it's 1114, some number of seconds, some number of milliseconds, right? So I could run this and it's using those milliseconds to give me a random value. If someone wanted to get that same value, all they would have to do is set the clock and then run it at the same time that I ran it before. which is really hard to do manually, but you can write a code that sets your clock and then runs the code. Does that make sense? You can't, but it can be done. So the pseudo-random aspect of that is that it feels very random. But for actual practice, like if you're using it to generate a security code, for example, right? It's not random enough because someone could hack in and adapt it. True random, they've been struggling with this idea of getting true random forever since they started trying to get random values. Like, what is truly random? What is something that cannot be replicated? They have used some sort of variation using time, but then also using measuring the amount of current that's coming in from coming out of your power supply, because it fluctuates, right? It's within a range, but it fluctuates, right? So using that power, they've been able to generate more random numbers, right? Because even though you can control it, it's harder to measure, harder to control than the time, right? But they've gone further. They've got like subatomic calculators that can create truly random numbers, but that is very, very high level programming. Pseudo numbers do good enough for us. So I say that to say, like, if you go out and you're talking on the forums and talking about programming and random numbers, there will be some jerk out there that comes back and says, you're not using random numbers. You're not using true random. And you don't have to defend yourself because they're jerks, but know that that's what they think they're talking about. But then how do we get random, right? Because in this case, every time we run random %10, it gives us 0, right? So there's a seed. It's an SRAND. How many of you have played Minecraft? I use Minecraft as an example because in Minecraft, you generate a world every time, right? And you can input a seed to tell it what world to generate, right? So if your seed is Peter Pan, then you're going to generate the same world every time you give it the seed Peter Pan, right? Which is good because I used to play Minecraft on hardcore mode and I would die and then your whole world gets erased. But if I remembered my seed, then I can jump back in and I know where things are. That doesn't matter. But that's the only way to play Minecraft. If you don't play on hardcore mode, then you're not doing it right. But SRAND is the seed. So what this does, SRAND times 0. All this does is it sets the seed for your random based on your clock. So your clock is measured in milliseconds. We can print it out if you want, but we don't need to. Time 0 is measured in milliseconds. This is what time is it right now. And the computer measures time in milliseconds. Eventually we adapted to be days and years and dates, whatever. But it's a millisecond measurement. Because we're setting a seed for random at time 0, when we run it, our random values are going to be different. So this time we got 6 and 524, 0 again, and 194, 2 and 858. Now we're getting random values.
You're expressing that as two different numbers.
Because I've got random %10 and random %1005. It'd be, I could do this to put a line between them, I guess. 6 and 180, 1 and 723, right? So these are random values, pseudo-random, random values. But let's say we wanted to control this. I could set my seed, instead of time 0, I can set my seed to 21. And then I get 4 and 187. Every time I run it with a seed of 21, I get 4 and 187. It does generate random values, right? But based on the seed. And this is why I referenced the Minecraft, because the seed is doing the same thing in Minecraft, right? Minecraft is generating some randomness to create the world, but it's using a seed to do that. Time 0 gives us our pseudo random. We could put another number in here, maybe time 10. Oh, no, you can't. It's got to be time 0. 0 and 24. Now, this is cool, right? Let's bring it back up. So now, in our game, if we were to scroll back up, we have a winning number, which was 7. We have a user guess and a count, right? Now, if we were to come back up to the main, and I want to just write it again, but for the sake of consistency, what we'll do is I'm going to change this if statement to a while loop, but I'm going to copy it and put it down in my new main. Is that okay with everybody? So that I'm not dealing with all of these if statements. So in my new main, let me go ahead and get rid of all of this. I've got an if statement that does check guess using a winning number, a user guess, and a count. So we need a winning number. I need a user guess, and I need a count. Count starts at 0, user guess starts at 0, and I'm going to get rid of these couts. So using my srand time and my random %10, we'll do 10 plus 1, because that'll give us from 1 to 10 instead of 0 to 9. Does that make sense?
Could you just stick in 11? Would it do the same thing?
If you stuck in 11, it would give you from 0 to 10, and I want from 1 to 10.
I got you.
But yes,
Oh, okay.
if you wanted the user to be able to guess 0, then.
Oh, I got you.
But this will never return a 0. So now we have check guess using a winning number, user guess, and count. I've already written this function. So I can come all the way up to my bool check guess. And I'm going to comment out my old main because I don't want that anymore. But my check guess should still be good, right? If guess equals win, then I'm going to, I wrote these if counts. You want in one guess or you want in count guesses. But if guess is less than win, it tells you guess too low. And if guess is greater than win, it's telling you guess too high. That's pretty good. That still works. The difference is if I put this in a while loop, right, then it's just going to cycle through here until I get my, until I get the number right. So I'm going to run it. I guess too low. Oh, I don't have anything where I'm actually getting the user guess. So let's do a cout, guess a number between 1 and 10. stdcin, and we're going to do user guess. Yeah, I think it would be better to just delete everything and start over for the sake of not pinging back and forth. I just want to delete everything in the main that we wrote last time. So I have my new int main that I've written today. In my new int main, I have an srand, which sets the seed. I have a winning number, which chooses a random winning number. I have a user guess, which I will store the user reply in. And I have a count, which I will increase with each user guess. So then I'm telling the user to guess a number between 1 and 10. I'm storing the user reply in user guess. And here I'm running my check guess function. In the event that the user guess is correct, I'm going to tell them thanks for playing. Right? But then I'm going to have to find a way to get out of this loop, right? Because as long as this returns true, it's going to keep cycling. So if they get the number wrong, it's going to kick them out of the loop, which isn't what I want. I want them to stay in the loop as long as they're wrong, and then get kicked out of the loop if they get it right. There's a couple of ways to change this. I can come up to the function, and if you win, I can return false. Does that make sense? When you win, it's false, and when you get it wrong, it's true, and that would make this loop work correctly. Or I could put an exclamation point in front of it and hope that works. Did I win? I did. I got it right the very first time on the first day. It doesn't matter. All right. So, because I put this exclamation point in here, what does that mean? It means not, right? So if this returns false, then this whole system is going to return true, or not false in this case. But because it's a Boolean operator, not false can only be true, and not true can only be false. My guess was 1. Where are you going? Yeah. Just some nuggets, 12 of them. Just 12 nuggets.
Grilled or regular?
Regular nuggets.
Just nuggets.
Just nuggets.
Okay.
12 of them.
Yeah, they grilled nuggets.
They do. Hey, look, all that's on the recording. All right. So, just a cool feature of Booleans is that you can use the exclamation point to mean not true or not false, right? So in this case, what I'm saying, while winning number does not equal user guess, right? There's a couple of things I want to do. I want to do count plus plus. Say you took a guess. I want to store that you took a guess. And then I want to say you have to guess again. So I'm going to copy this and put this down into here. And then after the loop, I want to tell you thanks for playing. So inside the loop, every time you guess, I'm increasing the count. I'm telling you to give me a number between 1 and 10, and then I'm storing your guess. Then I'm comparing your guess in my check guess function, giving you some feedback, and then cycling through. So what should happen, should guess a number between 1 and 10. I don't know what the number is because it's random. I'm going to guess 5, and I'm going to get it right because that sounds right. I guess too high with 5. I'm going to guess 2. I guess too high. I hope that we all know that that means the answer is 1. and it says I won in 2 guesses. Not quite right. Because we were using an if statement before, we were able to change the count before we process the result. Because it's a while loop, remember, it's going to change it after the result comes. We could order it differently, but all I'm going to do to solve this is come up and start my count at 1. Because I know that it was 1 off every time. Now, what's really cool is now with this program, I can set my winning number to 100 plus 1. And that means it's giving me a number between 0 and 100 instead of 1 and 10, or 1 and 100 instead of 1 and 10. So I can run it. I still don't know what the number is, but I know it's between 0 and 100. So 50, that's too high. 25, that's too high. 12, that's too high. 6 is too low. 9 is too high. 8 is the correct number, right? 6 guesses should never be more than 7 guesses, right? If you have 100. But I could set this to anything. I could give it a number between 1 and 1,000, 1 and 10,000. That's going to be really hard to guess. Or I could give me a number between 10 and 50. Right? Or between 1 and 500. It doesn't matter. Because I've written this program the way that I've written it, previously with the if statements, we would have to have nested 100 if statements, right? If the number happened to be between 0 and 1,000, right? But now we can use it with just this one while loop instead. You want to get something else really, really cool? Right now we're using a user guess. So the user is giving us a number. What if instead of that, the user guess is random between 100 and 1. The actual winning number is random between 100 and 1. At some point, the random value for user guess is going to equal the winning number, right? We can run it. I have to guess first. It took it 13 loops before it gave it the same number that it had started with.
So is the user guess is just throwing out another random number.
Right now, the user guess is just picking a number between 1 and 100.
But it doesn't, it's not smart enough to
Right.
guess whether you guessed high or low.
Right.
It's just throwing out a random number.
Throwing out a random number. Now we could make it smart enough, right? So that if you guess too high, right? Or if you guess too low, we could return something different than false. We wouldn't be able to do the Boolean, but we could have some feature, right, that said if this is false, then now your top number is 50, right? Or whatever it is. You could do that. It would take a little bit of work, but you could do it. But I like the idea of making the computer just play against itself. It did not do well. Took it 46 tries. What is the maximum number of attempts that the computer could have before it would get it right?
Except that.
Yeah, it could take it 1,000,000 tries. The number could be 10, and it never picks 10. It just doesn't, right? There's no way to make it pick 10 because it's random. Eventually it will, but that took 46 guesses. 44 guesses. Ooh, 50 guesses, right? Eventually, the idea of having the computer play itself, the randomness, is just, I think it's fun. What I could also do, the winning number is between 1 and 100. I could have it guess between 1 and 1,000 and run it. Now it's going to be too high the vast majority of the time, right? Because it's got 900 numbers that it could pick from that are not going to win. It's still going. Yeah, this is a lot more than I thought it would do. I may have done something wrong.
Maybe it's just a very, very dumb code.
Well, it is definitely. I mean, but eventually you think it's going to get it right, you know? Yeah, there, 3,971 guesses to get to whatever the number was.
Not smart, but fast.
That is pretty fast, right? It would have taken me a long time to punch in 3,971 guesses. But that's cool. That's the power of the random and the power of the loop. And you can do a lot of cool things with that. So I'm going to make a submission for the while loop game, I guess. All you really are changing is that one if statement, putting a not in there, and then making sure the while loop plays the game. But I'll make that submission, turn it in, and we'll call it a day.
Just stick your note in again.
Yeah, I'll put the note. I'll put the same thing I did last time. I'll copy this text over into the submission, so that you can get it. Yeah.